Thank you. I'm one of those people who's defined by what they were, where they've been. I always tell people I've retired 3 times. I'm very retiring. And I'm working on my 4th retirement. When I left Berkeley, many of my colleagues didn't really understand, how could one leave Berkeley? They thought this was heaven on earth, right? And I tried to explain it. I never could quite convince them. So finally, I told them in words that they understood. I said, I'm going to Taiwan into the family business. And that they understood. So today I'm going to talk about climate change. And this is kind of a grim topic usually, so I don't want it to be too upsetting. But, as President Kuo said, climate change is here. And in California, we see it in most dramatic ways in terms of fires that come every summer and stay for much longer than they do. This is one last year, went to Yosemite National Park. And how can we, this is a global phenomenon, so the solution should also be global. Solutions that are discovered in Europe and America should be used in Asia, and likewise in reverse. And I want to tell you about some of the work that we've been doing in a process we call supertorrefaction at National Tsinghua University, NTHU. And this was a picture in the middle is our first successful batch, and actually the members of the press, both from Chinese-speaking countries and English-speaking, were there, some of them. And some of you may recognize the person to the right. Okay? He is actually Eugene Wang, who was a vice president at Hong Kong UST. So even a Hong Kong representative was at this, and we're very happy. And finally, where it comes to molten salt and graphite, carbon technology, comes together in this picture here, which shows a piece of nuclear-grade graphite sitting in fluoride salt that's at 900 Celsius, and it's so hot that it's faguang, right? It's radiating in infrared and near-red wavelengths, so you can see it glowing. But it's not on fire, okay? It's not on fire. It's just heated, and it's not being corroded. So that's an amazing aspect of some of what I'll talk about. Anyway, this is a large group of people that's involved. You can see these names. Some are astrophysicists. They involve people from Hong Kong, like Professor C.T. Liu, crucial member of working on this problem. Some of you may know Yang Zubao, Ralph Yang, Yang Zuyou, the younger brother of Henry Yang, Chancellor at UC San Diego, and other people, all right, from industry, from Tsinghua University, from ITRI, from Zhongshan Keshe Yuan, CSIST, etc. Anyway, our inspiration comes from the past, okay, that climate change is reversible. That's the hope that I hope to transmit to the young people here. Often you hear we've passed the point of no return. It'll be 1,000 years before we get the climate that I experienced as a youngster. I hope to convince you today that's not true. We can actually reverse climate change on a time scale of about 25 to 100 years. And this hope for the future comes from something from the past, which is this black soil that is made by humans in the Amazon basin and was created, between 2,500 years ago to about 1,000 years ago, where through slash and burn agriculture, carbon, fixed carbon, got buried beneath the ground, more or less in the form of charcoal, and that has many beneficial aspects to sandy soils. These are poor soils, the water easily runs away, not much organic matter. So, when you grow crops, it doesn't have much. But when you put carbon into the ground, which is kind of the reverse of digging up coal from the ground and burning it, you put it back into the ground. You not only sequester carbon in a fixed form below the ground, but you increase the crop yield above the ground, and that's doubly carbon negative. Okay, so so let me give you the outline of the talk. First, I'll focus on replacing fossil fuels with synfuels. By synfuels, I mean fuels made from biomass using high-temperature chemistry. Okay, not biologically, which is too slow, but just the biological end, of course, is the plants themselves, but using high-temperature chemistry and other means. So we'll talk about this process that we call supertorrefaction, where we can make biomass into synfuel in 10 minutes. All right? And oxidizing, a way to burn, for example, one of the products, which is charcoal, in a way similar to one burns coal, but in such a manner under molten salt, such that you don't produce fly ash. People may know burning coal is bad because of the gaseous emissions, but it's also bad because of the particulate emissions. The reason why Beijing is so polluted is because of the particulate emission. Here you can do it without fly ash. And then reversing climate change by what I've already talked about. Something that is longer term is turning seawater into fuel. If you have a wish in Taiwan or in Hong Kong, what would you most like to use given the resources you have? Well, you don't have many resources, but you're surrounded by the ocean. Is there a way that we can turn seawater into fuel? That's a holy grail in some sense of much of what people talk about. And there's a way to use energy such that you can capture and sequester it, which is called bioenergy, carbon capture and sequestration. So even that becomes carbon negative. Okay? I'll talk about bridge from fossil fuels to synfuels, and then some take-home messages.